Now we've already looked at solving monic quadratic equations by completion of the square. We can also solve non-monic quadratic equations by the same method, in fact. In fact, it's not much different to what you've already seen. And while we haven't officially covered non-monic quadratic equations as such, and that will be covered later on, I don't think it's a bad idea to have a look at how non-monic quadratic equations could in fact be just as easily solved as monic quadratic equations by turning a non-monic quadratic equation into a monic one. So let's have a look at this example. So we have solved the quadratic equation 3x squared minus 10x plus 1 equals 0, and we're going to leave our answer in exact form, which means surd form. Okay, so what we're going to do, let's start off, and I might have to use sort of two parts of the board here. Let's start off by writing the non-monic quadratic equation. The first thing we're going to do now is convert this non-monic quadratic equation into a monic one. We're just going to divide both sides by 3. Okay, so we have x squared minus 10 on 3x plus 1 on 3 is equal to 0. Notice that just as long as what you do to one side of the equation you do to the other, you haven't changed the integrity of the equation at all. But what you've done now though is you've converted a non-monic quadratic equation into a monic one. Okay, the shortcut to all of this is obviously using the quadratic formula. Okay, so for those of you that know that, that's fine. For those of you that don't, it's great to see the relationship though between solving monic quadratics and non-monic quadratics, and it's practically basically the same method. All you're doing is just adding this one extra step. Okay, so why don't we now move the positive 1/3 over, because now we're going to do the completion of the square. Okay, on the left hand side. So x squared minus 10 over 3x is equal to negative 1 on 3. Okay, now let's complete the square. Okay, so we need to add something to both sides of this equation so that we can express the left hand side as a perfect square. Okay, so what we're going to do is we're going to halve the middle term. Okay, so half of 10 on 3 is in fact going to be 10 on 6. Okay, or 5 on 3, and then we're going to square square the half of the middle term. Okay, so 10 on 6. Okay, which is 5 on 3, and we're going to square that. So I might just write that. Okay. Okay, I might just write that there. What you do to one side, we do to the other. As such. Okay, like so. Okay, so now the left-hand side can in fact be expressed as a perfect square. So this is really the perfect square, x minus 5 on 3 squared. And hopefully you agree with this, because if you expand this perfect square, you'll have x squared. Okay, you'll have 5 on 3 x squared in the beginning, 5 on 3 all squared as the constant term, which is what, 25 on 9, and then you have double the product of the terms in the binomial. So x times negative 5 on 3 times 2 will equal negative 10 on 3 x. Okay, and that's equal to negative 1 on 3, okay, plus 25 over 9. Okay. Now, we can in fact combine, clean up the right hand side. Okay, so negative 1 on 3 plus 25 on 9 is 22 over 9. Okay, it's equal to 22 over 9. Okay. Now what we can do is take the square root of both sides. Okay, so what we'll have is we'll have x minus 5 on 3 is equal to plus or minus the square root of 22 over 9. Okay, x minus 5 on 3 is equal to plus or minus. Now square root of 9 is just 3, so that's, we can express this the surd on the right hand side as root 22 over 3. Okay. Now what we can do is add 5 on 3 to both sides. So move the negative 5 on 3 from the left-hand side to the right-hand side. So x is equal to 5 on 3 plus or minus square root of 22 on 3. Okay, and combining that into a single fraction, because it's got there's a common denominator now of 3. Therefore, x is equal to 5 plus or minus square root of 22 over 3. And the same result could be obtained using the quadratic formula.